Our next speaker's name is Afzal, and let me bring him on the stage. Yes. Hey, hi, Afzal. How are you?
Hi, I'm good. How are you?
I'm doing good. I'm doing good. So let me start with introduction. So Afzal is a senior Android developer, and he's working at Doist, if I'm pronouncing it correctly. And currently he's working on application called as Todoist, which I guess is a to-do application where we put what we have to do, and a Twist app. So what is this Twist app? Some game type, or like, can you give us a short
No,
information?
it's for sure. It's a asynchronous communications platform. Um,
Oh,
so it allows like instead of real time chatting and being online or getting notifications, it allows you to focus on work when you need to focus, and it'll have your notifications and messages for you when you return to it and need to communicate with people.
oh, nice, nice, nice. And your today's topic is mysteries of material container transform, right?
That's right.
Yes. So please turn on your screen share if you have something to share about. Oh, yes, we can see your screen, and the complete stage is yours, Afzal. So go ahead.
Perfect. Thank you for, first of all, for inviting me here for the talk. And thank you for arranging all of this. And I hope everyone is having a great time um, learning a lot of stuff. So I'm presenting Mysteries of Material Container Transform. Well, we'll get to that. But thank you for the introduction as well. So, what is Material Container Transform? Um, it's a shared element transition that takes the start view and an end view, and it morphs the start view into the end view. Um, there are certain things, certain limitations to it, but it allows you to transition between activities, between fragments, between two views, and between a view and a fragment. There are lots of customizations as it's a shared element transition. You get all the customizability of a transition and animators. But in addition to those, you get these as well. You can morph the shape of the start container or the outgoing container to the shape of the incoming or end container. Um, you can change the scrim color. So while the transition is happening, maybe the background needs to gray out or something like that, and it handles that for you. You also have the choice of picking the fade and fit modes. For example, fade modes are like crossfade or fade through or fade in or fade out. And fit modes are linked to, we'll discuss this later, but they're linked to scale mask progress thresholds where it tries to fit the incoming container to the not to the shape but to the proportions to the height width ratio of the new container. This also allows for creating reveal transitions within material container transform, and of course path motion. So you might have seen an example where a floating action button uh, goes like from the bottom right of the screen. It uh, goes in an arc or a path to the middle of the screen, and then it expands into the next screen. So that uses the path motion argument. And then we have the four progress thresholds that we're more interested in today's talk. There's the fade progress threshold, the scale mask progress threshold, the scale progress threshold, and shape mask progress threshold. They're a mouthful of words, so I might just shorten it to just say thresholds instead of progress thresholds. Um, what are these? So as you might have guessed, fade progress threshold um, is the part in the animation where the the start view fades into the end view. If we view this video over here, you can see that the first part of the transition was just a fade. That's because how we've set this over here is that the first 25% of the transition is a fade one, and the rest are at the end, just to clarify, what it looks like. And you see in the first 25% of the transition, it fades to the end view, and then the rest of them happen. Now, the part about the 25% is a bit misleading because it's not 25% of the duration. It's actually 25% of the progress as determined by your interpolator. So these progress thresholds are specific to the interpolator you're setting or the default one. And we'll talk about how that affects things in a later slide. But in code, this looks like this. You have the shared element enter transition for a fragment or a view. No, in this case, it's a fragment. And then you set the fade progress threshold from 0% of the transition to 25% of the transition. Let's see how the next one looks. Scale mask progress threshold. This was a tough one when I was trying to understand the difference between scale mask and scale mask and scale progress thresholds. But I hope this animation will clarify that. So in the first 25%, it might look like barely anything happened aside from positioning, but there is something happening here with regards to the ratio of the height and the width of the view. Here it's more square, like the proportions are more square, but as you go right here, you might notice that it's slightly more rectangular. And that's what scale mask does. It matches the proportion of the outgoing view to the proportions of the incoming view, so that when you apply the scale on it, it scales kind of uniformly like this. In code, this looks almost exactly the same. You have the scale mask progress threshold, and you define it just the same way as a fade progress threshold. Scale, how does that look? Scale progress threshold. Well, it does the part where it enlarges the outgoing view to the size of the incoming view. Over here, you can see it doesn't reposition it. Up until this point, it's just scaling it up. And then we have the scale mask coming in, which actually changes the proportions and increases the width only. So you can see that's the difference between those two. And finally, we have the shape mask progress threshold. And you can see I didn't follow the previous slides for this one. And I'll tell you why when you look at this video. If you notice the corners, they went from, I think it's 8 dp to 4 dp. And it wouldn't have been visible if it was just a small floating action button up there. It would have looked like 0 dp corners. So it's just scaling up to show you, but the real thing I want to show you is a change in radius as it morphs. So those are the 4 progress thresholds. Now, that's all fine, but when you get a prototype from your design team and it's in a different software, like for example, the Doist team uses Principle for sharing animations, and you're like, how am I gonna implement this exactly? You can go by eye, of course, but it's going to take a long time. And this presentation, the next part of it, will show you how to do this systematically. So it's a really neat transition in the prototype, if you want to agree with that. But there are some tricks that they've used because probably the animation software can't morph from one view to another. So you see that there's a little dot in the middle of the floating action button, and that's the thing that enlarges. So there are these tricks that you get in design, and now you have to implement it proper, figure out what thresholds you should use. This was the result last year when I worked on this. It's a bit fast, I know, but I hope you agree that it is pretty close to the result. There's also the keyboard aspect, which we'll talk about briefly, but I want to focus first on how to set the thresholds, and then I'll explain a little about the keyboard. First things first, our views aren't at the right place. Our floating action button is on the right side. It needs to be centered, and it needs to be round. So that's not a big problem. You just center it horizontally, and in material 3, you apply the shape appearance overlay. Um, that changes the shape of the floating action button. Secondly, the end view. If you remember from the prototype, the end view is not this tall, nor is it hitting the bottom of the screen. It's in the middle of the screen, right above the keyboard. For demo purposes, we'll hard code the margin, the bottom margin, and the height. Later on, when you actually use the keyboard insets, then the margin will be set depending on how tall the keyboard is, because people might be using different keyboards, and you need to determine the correct height. Okay, so once that's done, we need to figure out what fade progress thresholds to set. Over here, you can see nothing is really fading, cross-fading, but we need to figure out when to do that. And I think it's suitable to say that as soon as the incoming view is overlapping the fab, the floating action button, that's when it should complete the fade part of the animation. So that's around, if you look at this line here, that's around about 20%, 60 milliseconds of the transition. So we're going to say 20% over here. And then we're going to run our animation. Right? And it should finish in 60 milliseconds. But you can see I added this text view to show you that it's only finishing, it's in 40 milliseconds for some reason. So the progress thresholds are wrong? Well, yes, they are. Remember when I said that the interpolator, the progress thresholds depend on the interpolator. We then need to figure out what fraction of the interpolator is 20% of the duration. For the default interpolator, it's this, 0.633. The way you do it, I think the easiest way is, doesn't matter if you're using a custom interpolator or the default interpolator. Set a listener in the transition start, because that's when the interpolator gets set when the internal animator is created, and then figure out what the value is. So we set 0.2. Well, we get the result of the 0.2 duration, 20% of the duration, and that would be it if your design team was using the interpolator that is used by material components by default. But as you see in this principal app, the one that our design team used, the default interpolator is actually something different from the built-in Android interpolator. So we're going to set the custom interpolator now to avoid doing the work twice and calculating all the thresholds. So how do you do that? You just set the interpolator over here with a path interpolator. Thankfully, in this app, the X1 and Y1 and X2 and Y2 are right there. And also, thankfully, the design team picked the same interpolator for all of these. If they didn't, I think that would be much more difficult, if not impossible. I don't want to say impossible, but it would be much more difficult. So we set that, and then we use the same breakpoint and calculation to figure out what 20% of the duration means for this interpolator, or the progress of this interpolator. That is 0.295. So we set that, and we hope this time we're right. And you can see, I can play the animation, but you can see at 61 milliseconds, the fade part of the transition is complete. Woohoo! So we go to the next part, scale mask. Now, again, the prototype doesn't scale the floating action button. It scales a little dot coming from the center of the floating action button. That's not the same. We shouldn't start the scale animation from the beginning. Instead, what we can do is see that, okay, this is where the width of the containers match, like the floating action button and the incoming view, their width matches. So that's where we should start changing the proportion of the floating action button to match the proportions of the incoming view. So in this case, that's 13.33% or 40 milliseconds. We do the same break, hit a breakpoint and then do the calculation for the interpolator, and we come out to 0.154. So we say start scaling or scale mask progress from 0.154 progress along the animation, and finish it when the animation is complete. That's the second value over here. How does that look? That looks like that. So we have the fade part happening because this is already set. Oops. This is already set down here, and the interpolator is also there. When it reaches 40 milliseconds, it starts to change its shape a little as it goes. The width increases until we need to scale. Going forward, 2 more left. How do we set the scale progress thresholds then? In our prototype, if you remember, the scaling and the scale masking, if you will, happen at the same time. They're not staggered. So we're going to use the same value and see how that looks. And it's looking acceptable now. It's almost there. But the shape is doing its own thing right now. I think the shape is changing later than we'd like to. So the shape mask progress threshold helps us with that. Now that looks weird here. So the radius starts changing at halfway through the animation. So 300 millisecond animation at 150 millisecond, we have the radius starting to change, but in our interpolator, that means 0.8%, like that means 0.8 of the progress of the interpolation. So we'll set that. We know that that's the correct calculation, from the previous experience. So we'll believe that, and we set that. So that's it, right? So how does our animation look? Let's look at the prototype here. That's the prototype. And then the return animation right there. And then we have ours. Enter transition, looks pretty solid. And then we have the return animation, which is not solid at all. So if you see here, the return animation is following the progress thresholds of the enter transition. The radius isn't changing until the last part, the corner radius, and fade is happening too soon. So this return transition isn't what would be if you reverse the enter transition. So how do we fix that now? I'll tell you the reason. The reason is that we specify in the return transition, we specify that the transition direction is return. But that only works when you don't customize the thresholds. If you customize the thresholds, then you have to define the return thresholds as well. There's no automatic calculation built into the material components library. Thankfully, that's not very difficult. All you have to do is figure out the opposite part of the animation for each threshold. So for fade, we're going from 0 to 0.295. When you're coming back, that part of the transition when coming back is going to be 1 minus 0.295 to 1. So 1 being the end of the animation, we start near the end because that's where we faded when we were entering in that position of the view. Same with the rest of them for scale mask and scale and for shape as well. And then this is how it ends up looking. That's the enter transition, still good. That's the return transition. That looks pretty solid to me. But now let's talk about keyboard. You're going to say, Afzal, you skipped the keyboard. What are we going to do? The padding isn't correct. So synchronizing IME animation with the container transform animation requires listening to the insets using the inset animation listener, if I'm naming this correctly. And that tells you what the bottom padding will be when the keyboard is about to show up. And the other part of that is controlling the keyboard animation. So when the keyboard starts showing up, we can start our animation, right? The way we do it, at least the way I did it in Todoist, was we didn't use the shared element enter transition. Instead, I used just the enter transition, and we postponed the fragment enter transitions in the beginning. When the keyboard was about to show up, we try to show the keyboard when it's about to show up. We start the postpone transition. We set the bottom padding and we start the animation. That way, when the animation starts, the container is positioned correctly. On API 30 plus, we also wanted to control the keyboard animation because on older APIs, what would happen is the keyboard might show up too early. I don't know why, but it might happen. And so we want to control the keyboard duration as well. And that's available to do on API 30 plus. So that, I believe, uses a window insets animation controller or insets animation controller. So we use that, and that's what the demo was in the beginning before I started implementing the prototype, where the keyboard is meeting just right in the middle, all lined up. But sometimes things aren't as perfect, and sometimes transition isn't seamless. And what I mean by seamless is you might have like a color that's not changing properly. It's not fading properly, or it's fading to some other color and then immediately switching. That could happen if your container color is not being derived from the ID or the view. That's the end view or the start view. In that case, the container color arguments are your friends. You set the start container color to the color that is actually supposed to fade from, and you set the end container color, and then it will transition that color until the animation finishes and your view takes over and it shows its correct color. The other thing is shapes aren't transitioning correctly. Before shape appearances and all that, we had other tricks. We had 9 patches and all that to put rounded corners and things. And you might still be using them, or maybe you're using something else and it's not transitioning correctly. So what you do is you set the start shape appearance model and end shape appearance model on the material container transform instance. And then it seamlessly transitions. And once the transition is over, again, your view takes over and it shows up the exact same thing. So it doesn't look like it's a hack or something. What else can go wrong? Animation might look perfect in slow motion when you're developing. You're You have the animation scale differently. But in real time, there's something wrong. Like I had this problem for months after implementation. I was like, why is why is it that it just looks off? It doesn't look perfect, just like the prototype. Um, and then one day I decided I'll record a slow-mo video from another phone and see what's really happening. And this was happening. This is on API 30 plus. Where's the fab? It's the floating action button is hidden behind the keyboard because the keyboard is popping up too early. Or not too early. It's actually not popping up too early, but the R transition is starting slightly late. So when you see this in real time, you don't connect the floating action button to the final thing. You connect something that's happening behind the keyboard, and not really. There's no morphing or anything really. Your mind doesn't connect that. Unfortunately, the solution for that was for API 30 plus, just delay the keyboard 50 milliseconds. When I did that, now you see the morphing clearly. So that it's not ideal because you're delaying the keyboard showing up 50 milliseconds, but it's also not very noticeable when there's so many other things happening on the screen, like the animation. I recently told this to somebody and they were like, oh, I would never realize that that it was delayed. So that's a trick to use. Now, there might be a case like it was for us where you're not using the shared element enter transition, what do you call it? Or the shared element return transition setter in your fragment. Instead, you're using the normal one, the enter transition and exit transition or return transition setter, because in our case, the floating action button was in a fragment that contained the incoming fragment as well. So we couldn't replace that fragment. So we had to set a start view and an end view, and that way it worked. But the return transition did not. Turns out that if you don't set a target view, the return transition, or I guess even the enter transition, will try to look at the whole scene. And I guess for some reason, it didn't recognize that the container was the thing that was missing. So the way it got solved is I added a target view referring to the fragment container view that contained the quick add or the big container fragment. And then when the return transition started, it detected, okay, that's the container that needs to be dealt with. So that started working at that point. Dark themes might also make the fade part of the transition a little bit different. As you can see here on the left side, there's a floating action button right here, but you can't really see it against the dark background. And that's like 3 frames into the transition already. The fade is too sudden, and you don't really connect the floating action button is the thing that's morphing. Simple solution for that was delay the fade transition a little bit more. Instead of starting straight from the start, start it when the fab has moved a little so that it's more seamless. And I think when I play this animation is going to change slides, so I apologize for that. Yeah. Anyway, what about Jetpack Compose? So, material container transform, old Android views, like that's old stuff, right? Not really. But Jetpack Compose has its own thing. And right now, there's no official way there's no official way to transform a floating action button or a shared element to another part of the screen or another view or another composable. But there is a cool thing coming out. Hopefully, in the next alpha, there will be a layout called Look Ahead layout that computes the starting views measurements and the the end views measurements, or I don't know what to call them. They're not views, and it animates them, or it has a framework for animation. The modifier, I think it's called animate layout. That's still not merged yet, but it's coming up, and it's going to be pretty exciting because then we can do all these neat animations in Jetpack Compose. Well, that's about the end of this talk, but here are the resources. This is my GitHub right here. This is the repository for all the demos that I showed in this talk. It's available in code. You can check it out, play with it, see how things are affected. And here are the blog posts and code that helped me figure out how to do this properly, especially the keyboard animation part. So check it out if you're interested in creating animation with Material Container Transform. And finally, questions. But before we go to questions, I want to thank Geekle, and I want to say that you guys have done a really great job, organizing all of this.
Thank you, Afzal. That was a nice session on material containers and how we can use transform to give the animation. And you showed us some of the sleek animation that I was imagining how the developers are doing it. Because in Flutter, I usually use the hero animation, and
Mm-hmm.
it gives us that animation effect, like the image can go from one screen to another, and it appears that the image is moving from a position of the previous screen to the position of the next screen. So is it so can we use this in material transform as well?
Yeah, I mean, material container transform is like a subset of the shared element transition, right? And shared element transition is what you use to transform the image to the hero image. So I don't see why not. Say you have a grid. Well, I haven't tried it in a recycler view. I'm guessing it has to do with stable
Let's
IDs
say
and stuff.
let's say we just have two views, like screen one, screen two, and when we are navigating we want to show that is going from the first screen to second screen, but in a such a way that it is popping out from there. So I
For
think
sure,
with
yeah,
yeah.
this should be possible, and you can like show like customize the path, and if the shape is different, if it's rounded corners to non-rounded corners, and you can do that, definitely.
And how difficult is the math in this?
Not so much. Like, I only realized this progress threshold business yesterday.
Oh.
In to
Because
do
like
list,
I think like if we have to hard code that the delay 50 and the delay that we add, I think that might create some issue in some other codes or in some other devices.
100%. There's some amount of testing involved, which is why I waited like a whole year of issues coming up before I started talking about it. But yes, aside from the delay of the keyboard, everything was not so not so hacky. uh, the progress thresholds, of course, you have to hard code them because they're dependent on which part of the animation is going to happen when, right?
Yes, we have few questions from our viewers, so I will just add them to our screen. So the first question we have is: are material containers tied to the view holder?
Well, view holders come up when you use recycler views, right? But as you saw, we didn't really use any recycler view in our demo. Um, so I believe no, they are not. But the way to, if you are using recycler view, the way to do it is assign like a different transition name to every item. That way, the material container transform will know which one to transform when you click it.
Oh, okay.
Mhm.
Like, is it attached to our activity, the Kotlin
It's
activity or any activity that we create?
it can be attached to it is you can transform an activity to another activity, or just fragments, or just views as well. Essentially what it does is it creates a drawable, I think it's something like animated drawable or something, where it's just showing the views but in drawable, and then transforming that drawable until it's finished, and then it shows the actual view.
Okay. Next question is about Scrim. Does it handle status bar?
It does, but once the transition finishes, the status bar is going to go back to the color it was. So what we do is we set a listener for transition n, and that's when we set the status bar to the transitioned color. And then vice versa, on the return transition, um, you you do the opposite, where you change the alpha back to, or not the alpha, the the alpha of the whatever background view you have, you change it back to be invisible, I guess. And status bar, you change the status bar color along with that.
Okay.
Same.
Another question that we have is the prototype open sourced,
Yeah,
one that you have created?
yeah. I linked it, and it has different branches for different parts of the. Oh, well, the code is, but not the principal prototype. I can ask the designer and the Doist team here if I can put it out. I'm not sure if that will be allowed, but we'll see.
if
If it is, then
if
it'll be in the repository.
if it is case sensitive, then we'll have to officially hide it as well. Uh, there is one more question, and I think that question, it's divided into two forms. The first question is, have you considered translating the new task field with the same speed as the keyboard? Is it possible?
Yeah, that's the first thing I tried, and it was too fast. The thing is, if one of the frames just jumps, because the interpolator is, calculating from one frame to another, and the fade just happens in one frame, that's too sudden. I that was the first thing I tried, because I was like, I don't want to modify the keyboard duration. That'll make things slower. But it that transition was too fast, and at least on my Pixel 3a, it was also janky. So had to slow it down a little.
Okay, and I think he just checked your Todoist app, and it is clear that there is a blank space between the keyboard and the rectangular view for some time before one comes to another.
That is not related to material container transform. It's hilarious that this person found this bug.
I know.
Um, it's a bug
Yeah, but we
related
can use it
to
for QA testing now.
yeah, it's a bug related to showing the snack bar while the quick add is showing. We'll prioritize that bugs at some
Now
points.
I have like another question now. Like, let's see. Firstly, how will these animations and these transforms that we are using affect the performance of our application? Like,
Mhm.
if example, like we just have to show a dialog box, then there won't be any lag. But now we are adding the animation, so we will increase the processing power. So how will this affect the performance of our application? Also, do we have to manipulate between the refresh rate of a screen? Let's say if we have 60 hertz and if we have 120 hertz now, which is
Mhm.
coming nowadays. So do we have to alter something, or the Android will do it on its own?
Well, for the most part, the refresh rate will be handled automatically. But I think that that part, where I showed that the keyboard was coming up too fast, my hunch, I have to try this on a Pixel 6 or whatever is 120 hertz. But my hunch was that that's only happening in 60 hertz, because you don't have the time to draw the middle part. But I don't know. But the first question was, sorry, what was the first question?
About the performance, like will it hamper the
That's right.
performance or will it drop the refresh rates?
Right. It won't drop the refresh rate, but we did put in this thing. in there for when the keyboard is delaying too much. Um, for whatever reason, sometimes the keyboard isn't showing up quickly enough, and we need to show the quick add at some point. So we just added, I think, a delay of 300 milliseconds before it reverts to the way it was, and the way it was just show up. So that way, in worst case scenario, you don't see the animation, but at least the functionality is preserved, and you see
Okay.
it in time.
Okay, that's it from me. And thank you, Afzal, for having a precious time with us and sharing the knowledge that you had. I actually enjoyed this session a lot because, like, building the UIs is the thing that we do, and creating these animations is what attracts the users right now and keeps them glued.
Sure,
So,
for
this is
sure,
what we are doing in our day to day lives when we create applications. So, it was a nice session to know how we can do it. So thank you again. Thank you again for being a part of Geekle and showing this to our viewers.
for sure. It was my pleasure. Thank you for having me, Shri, and thank you for all the questions.
Yeah. Thank you again. Okay. Bye bye.
Take care. Bye.